Hello everyone, welcome back to Maths Zone. My name is Ravi Kumar. Today in this video, I will explain the graphical representation of cumulative frequency distribution and obtaining median from Ogive curve. This is very useful to 10th standard students who are studying CBSE syllabus, ICSE syllabus, AP and TS state syllabus. Without wasting any more time, let's get started. Cumulative frequency curves, also called Ogive curves. The term Ogive is pronounced as Ogive and is derived from the word OG. An OG is a shape consisting of a concave arc falling into a convex arc, so forming an S-shaped curve with vertical ends. In architecture, the OG shape is one of the characteristics of the 14th and 15th century Gothic styles. Cumulative frequency curves or Ogive curves are two types. First one, less than type cumulative frequency curve. Second one, more than type cumulative frequency curve. In this video, I will explain all these by using an example. The example is the following distribution gives the daily income of 50 workers of a factory. Daily income in rupees. Number of workers 250 to 300 12, 300 to 350 14, 350 to 408, 400 to 456, 450 to 510. Here the given data is grouped frequency distribution. To represent this grouped frequency distribution into graphical representation of cumulative frequency distribution, first we have to prepare cumulative frequency distribution, that is less than cumulative frequency distribution and more than cumulative frequency distribution. To draw less than type cumulative frequency distribution curve, first we have to prepare less than cumulative frequency distribution. Here I will prepare a table of form. In first column, I take daily income in rupees. In second column, number of workers. In third column, upper boundaries. Fourth column, less than cumulative frequency. Fifth column, less than cumulative frequency curve points. First class interval is 250 to 300. Frequency is 12. The upper boundary of this class interval is 300. Less than cumulative frequency means number of observations less than the upper boundary. So less than 300 equal to 12. This point is 300 comma 12. Second class interval is 300 to 350. Number of workers 14. Upper boundary of this class interval is 350. Less than cumulative frequency of 300 to 350 class interval is number of observations less than 350. That means 12 plus 14, that equal to 26. This point is 350, 26. Next class interval 350 to 400. Number of workers 8. Upper boundary of the class interval 350 to 400 is 400. Cumulative frequency of 350 to 400 is the number of observations less than 400. That means 12 plus 14 plus 8 or 26 plus 8, that equal to 34. Point is 434. Next class interval is 400 to 450. Number of workers 6. Upper boundary of the class interval 400 to 450 is 450. Less than cumulative frequency of 400 to 450 class interval is number of observations less than 450. That means 12 plus 14 plus 8 plus 6 or 34 plus 6 that equal to 40. Point is 450 40. Last class interval is 450 to 500. Number of workers belongs to this class interval 10. Upper boundary of the class interval is 500. Less than cumulative frequency of 450 to 500 class interval is, that means number of observations less than 500, equal to 12 plus 14 plus 8 plus 6 plus 10 or 40 plus 10 that equal to 50. The point is 550. To represent the data graphically, first we have to draw horizontal line, that is x-axis, vertical line to x-axis, that is y-axis. Now mark upper boundaries on x-axis and their corresponding less than cumulative frequency on y-axis. Then let us choose scale on x-axis 1 centimeter equal to 100 rupees. Scale on y-axis 1 centimeter equal to 10 workers. Now I plot first point 312 on x-axis. 300 is here. On y-axis 12 is about 10, that is 10 after 1 2. So 312 point is at 300 units away from y-axis and 12 units away from x-axis. So the point is here. Similarly, second point 350 26. This point is at 350 units away from y-axis and 26 units away from x-axis. Here we have to plot 350 26. Next I plot third point at 434. Fourth point at 450 40. Fifth point at 550. Now we have to join all these points. This curve is called less than cumulative frequency curve. Now I will explain more than type frequency distribution curve. First we have to prepare greater than cumulative frequency distribution or more than cumulative frequency distribution. In the table of form, I will take class intervals, that means daily income in rupees, number of workers, that means frequency, lower boundary of the class interval, greater than cumulative frequency, greater than cumulative frequency curve points. First class interval 250 to 300. Corresponding frequency is 12. Lower boundary of this class interval 250 to 300 is 250. Greater than cumulative frequency means number of observations more than or equal to lower boundary. That means number of workers income more than or equal to 250 is 12 plus 14 plus 8 plus 6 plus 10 that equal to 50. Point is 250 50. Second class interval 300 to 350. Number of workers 14. Here lower boundary of the class interval is 300. Greater than cumulative frequency of this class interval means number of workers who have daily income more than or equal to 300. They are 14 plus 8 plus 6 plus 10, or here 50 minus 12 that equal to 38. Point is 338. Third class interval is 350 to 400. Number of workers 8. Lower boundary of the class interval is 350. Here greater than cumulative frequency means number of workers who have daily income more than or equal to 350. Here 8 plus 6 plus 10 are 38 minus 14 that equal to 24. Point is 350 24. Next class interval is 400 to 450. Number of workers 6. Lower boundary of this class interval is 400. Greater than cumulative frequency of this class interval means number of workers who have daily income more than or equal to 400. That means 6 plus 10 are 24 minus 8 that equal to 16. Point is 416. Last class interval is 450 to 500. Number of workers 10. Here lower boundary of the class interval is 450. Greater than cumulative frequency of this class interval means number of workers who have daily income more than 450. Here we have only 10 workers have their daily income more than 450, or 16 minus 6 that equal to 10. The point is 450 10. To represent the data graphically, I draw horizontal line on the graph paper, that is x-axis, vertical line to x-axis, that is y-axis. To draw more than type cumulative frequency curve, we have to mark lower boundaries on x-axis and greater than cumulative frequencies on y-axis. So let us choose convenient scale. On x-axis 1 centimeter equal to 100 rupees, on y-axis 1 centimeter equal to 10 workers. Now I plot earlier prepared points on graph paper, then we get greater than cumulative frequency curve. First point 250 50. To plot this point, we observe 250 on x-axis and 50 on y-axis. So here we mark this point. Second point is 338. This point is here. Third point is 350 24. This point is here. Fourth point is 416. This is here. Last point is 450 10. This point is here. Now I join all these points. This curve represents more than cumulative frequency curve of the given data. Now I explain how to draw two ogives on the same axis to represent both less than type and more than type cumulative frequencies on the same axis. First I draw a horizontal line, that is x-axis, and vertical line to x-axis, that is y-axis. Here we have to mark lower or upper boundaries on same x-axis and cumulative frequencies on y-axis. First we mark less than type cumulative frequencies on the graph. We mark first point 312, second point 350.26, third point 434, fourth point 450, 40, fifth point 550. Now I join all these points. Next, now I plot all the points of more than type cumulative frequency the same graph. The points are first one 250 50. This point is here. Second point 338. This is here. Next third point 350 24. This is here. Next fourth point 416. This point is here. Last point 450 10. This is here. Now I join all these points. This is the graphical representation of both ogives on the same axis. Now I explain how to obtain median from ogive curves. Here we have to obtain the median in two ways. In first way, we obtain the median from either less than cumulative frequency curve or more than cumulative frequency curve. In second way, we obtain the median by drawing both ogives. Let us take first method. In first method, first we have to locate n by 2. N means total number of observations, here total number of workers, that is 50 by 2. 225 is of 50, that equal to 25 on y-axis. From this point, draw a line parallel to the x-axis, cutting the curve at a point. From this point, draw a perpendicular to the x-axis. Foot of the perpendicular determines median of the given data. Now we mark the n by 2 value 25 in less than cumulative frequency curve graph on y-axis. From this point, I draw a line parallel to x-axis, cutting the curve at this point. From this point, I draw a perpendicular to x-axis. Here, the intersecting point at x-axis represents approximately 350. Therefore, the median of the given data is 350. Now, I will take greater than cumulative frequency curve. Here also, I mark 25 on y-axis and draw a parallel line to x-axis. I mark the intersecting point and I draw a perpendicular line to x-axis. This perpendicular intersect x-axis at 350. Therefore, the median of the given data is 350. Let us take second method. In this method, we mark the intersecting point of both ogives. From this point, I draw a perpendicular to x-axis. The point at which it cuts the x-axis that gives the median of the given data. Here, the perpendicular intersect at 350. Therefore, the median of the given data is 350. I hope you understood the graphical representation of cumulative frequency distribution and obtaining median from Ogive curves. If you have any doubt, write in the comment section. Thank you very much for watching.